Hi, and welcome to our talk. Thank you so much for being here. I hope you are enjoying the conference so far. We are going to talk about the human factors in data creation, which is why our talk is called Help, There Are Humans in My Data. I'm the data person of the two of us. I'm currently a member of technical staff at Cohere, but in the past I've worked as a data science educator, as you can see from the picture, and other technical roles like machine learning engineer. And then next to me is Isabelle.
I'm very much not a data person, at least not in the sense that I know much about the technical side of data science. I work as an advisor on responsible implementation for governments on AI and data practices. And I spent 4 years, the past 4 years, struggling through a PhD at the Netherlands Police, also studying how they actually do things with data and create data science models and stuff. But you'll hear a lot about that. And this is a picture of my dog reading my dissertation.
So before we actually talk about the human factors in data creation, I want to talk to you about this other data set that you might be familiar with. We also talked about it in Vincent's talk, which is the Titanic data set. So this dataset was my very first introduction to machine learning and data science. It's this Kaggle competition called Titanic Machine Learning from Disaster, hosted on Kaggle, which is a platform that hosts competitions for machine learning. And the aim of the challenge with this dataset is to predict whether people survive the Titanic disaster. And it's a very good introductory dataset to use. It's a little bit morbid, I think, and it's also not really about a practical use case, because obviously we already know who survived the Titanic disaster and who didn't. But it's still a really good data set that gives you an insight into how machine learning works when you first get started as a data science student. So the data set looks something like this. And this is the data set that taught me about one-hot encoders, imputing your missing values, how to detect outliers. And it even taught me about feature engineering and how to think critically about your data. For instance, in this data set, it turns out that your chances of survival are a lot higher if you have a long name, which is either something that's really random, because obviously that's just chance, but it could also be considered like a proxy for social class, of course. So this is a good data set to get started with, and but what I didn't realize at the time when I was doing my first data science project with this is all the work that had gone into collecting and discovering the data to make this data set. Because the data set that we know is actually the third version of the Titanic data set. There wasn't one single nice historical document that holds all the information that just turned it beautifully into a data set that we could use. It's actually the combination of researchers that studied all these old documents and then combined all that data and made 3 different versions of it. And I think that's interesting because nowadays we use a data set like this to do some analysis, answer a question like, did women in fact survive the disaster more often than men did? But that cannot have been the purpose of creating this dataset or these documents in the first place, because obviously data analysis wasn't the core purpose of these type of documents back in 1912. So obviously times have changed. Nowadays, many organizations realize that the power that data can provide, and they do want to collect data, not the way that we see here with all the scribbles on all those documents, but there are more, well, I would say better-ish systems, like data entry systems that we have here. These are not primarily made to make really nice and clean data for us, as you might expect, but they usually exist in some way for people who are actually using this data to communicate to each other. So it's a paper trail or to standardize communication. So for instance, a nurse doesn't write down the vital signs of someone in the ER because she thinks, okay, that's really cute, then there can be some data scientist out there some way that can make a model about when to discharge a patient. But that nurse writes it down in a system like this to just as information for the next nurse that is on shift or the next doctor that's going to treat this patient. This means that although Although systems that are used to create and collect data are more efficient and coherent than they were before with all the scribbles on the documents, they still have one thing in common with the Titanic dataset scribbles that we saw before, which is that they're still really dependent on humans to create this data, and that these humans don't have the intention of creating really nice, clean, usable data for us as data people, essentially. So that's what we're talking about today. About the data that comes from organizations where data is a byproduct of other work. And while I'm a data person who's done countless of work on the analysis side, the modeling side of all of this, doing the dashboards and visualization and models, we will also talk about the process of creating that data. And for that, Isa is actually a more qualified person to talk about this.
So yeah, as I already mentioned, I did my PhD research at the Netherlands Police, and one of the core types of data that they use a lot, and that's also typically this byproduct of other work, of course, is police reports. Police reports are used, for instance, in the Dutch predictive policing software. They're also used in several types of risk assessments, and also a lot of stuff still under development. But even looking at the future, it's quite likely that this is going to be used more and more often. Exactly because this is data we just have lying around. It's readily available for the organization, even if it's never created with that intention at first. Yeah, and I think that's actually really good news, because police reports are a very rich kind of data source, and it would be a shame not to do anything with that kind of data. But police reports, of course, are written by police officers and very much not by data scientists. What officers do is they translate incidents that happen during their workday into a registration software system. And then later on in the process, this is used by different people, data scientists like you, as data. The thing is that police officers, they don't really know anything about data science. They don't know what this data is going to be used for other than their direct work. And also, they don't really care at all. What they care about is doing a good job as a police officer. And I think we should be happy about that that's their main concern and not so much the analysis part. On the other hand, you have data scientists who also don't know much about this street-level administrative work that's policing, right? So that's where I came in with my PhD. I did observational research, ethnographic work, and I spent about 350 hours joining police officers on shifts to see how they went about creating this data and how that then may later affect interpretation thereof. So I have a bunch of examples in this presentation, but for the first one, I want to put you guys to work. So there's going to be a question after this little story. I want you guys to imagine that you are a police officer for a second and you're working in emergency response. So you're sitting at the desk, your shift is almost over. You've had a crazy busy day with a lot of emergencies, which means that you really didn't have time to work on your reports until right now. Even though you really just want to go home and you're quite tired, you still have to finish those damn reports. So you're about to start the first one, which is about a call that you got this morning. A woman was sitting on the sidewalk. She was screaming stuff about Russian cyber attacks, and she was threatening people a bit, so they didn't feel very safe and called the police. As you arrive on the scene this morning, you realize that you actually know this woman quite well. And it's a really sad case. This woman, she's had a really tough life with a lot of mistreatment. She's dabbled in prostitution, and she regularly commits small crimes, such as theft, in order to make ends meet. She is a homeless person as well, regularly gets into fights at the shelter, which is why she's sitting on the sidewalk. And she also has a tendency to drown her troubles in alcohol, and the half-empty bottle of vodka sitting next to her is a testament to that. Today, really nothing happened. You warned her off, and she seems to have listened because you haven't heard about it for the rest of the day. But now you have to report that. So what you do is you open the registration software, which looks like it came straight from the 90s, like the example Marysia also showed. And the very first question it asks you to fill is the incident code. Now, finding the right code is important because, on the one hand, it determines what other steps can follow, for instance, juridically. But it also determines, and we'll get more on that later, it also determines what other fields become available and what other information you can add to your police reports. Now, and here's the question for you guys. I made a little pre-selection of potential incident codes for this situation, and I'd like to see a show of hands for which code you think you would pick for this scenario. So is there anyone who would pick A, disturbance by a homeless person? Just a few hands, yes. And B, confused? A few more people going for confused. Drunk? Finally, we would pick D, other. And this is what I'm always hoping for when I ask this question. It's an almost equal distribution of answers. Clearly, there really is no correct option here. Right? All of these apply and are accurate to a certain extent. And you can imagine that an officer in practice has a lot of discretion in trying to pick the incident code. I think we had a slight majority for a drunk person here. So in terms of data, this woman is now, she has become a drunk person, which is a kind of reality that has now been created, right? And knowing the backstory as the police officer, we know that that really doesn't do any justice to the very complex situation she's in. But as a data scientist, most of the time would look at this data, it seems really objective and clear. Okay, this is just a drunk person causing some disturbance. The thing is, the world that we live in, it's a messy place, and it's quite difficult to neatly place something that happens in that world into a predetermined box or category. And it becomes even more difficult if you have to pick between 685 such boxes, because that's how many incident codes there were at the police when I did my research. And I think it's more now, because that number has been steadily increasing ever since the 80s. Now, sometimes officers really try their best to find the most accurate code, even if it's difficult or even if possible at times. But sometimes they also have different motivations. And now we get to that part where I said the choice you make also determines what other information you can add. For instance, the code determines what role you can give to a person. Some codes, for instance, like arguments or conflicts, they allow the officer to pick between a victim, a suspect, but also a more neutral role, like a bystander or an involved person, so very neutral roles. But other codes, like vandalism, for example, they don't have that option for a neutral code. So if the officer thinks it's important to add a person in a neutral role, then they might opt for the less accurate code in order to fit their professional opinion, because again, they care more about doing a good job as a police officer than they care about data creation. Now, this is, of course, one example, but many search forms have these kinds of follow-up things where what you pick first determines what you can add later, and even what a next officer working on that same case can do. Sometimes choices really get locked in.
And obviously, this problem is not unique to the Dutch police. A lot of organizations suffer from the same problem, where there are a lot of different options for categories. And very often, the option that you pick really determines what other options you get to pick. I don't have the same experience as you. I didn't go to the street and walk with police people, but I have experienced this in life. So I remember being very frustrated, for instance, back in my student days when I was living in a studio, and there was a leak in my, I'm not sure what the English word is, the meter cupboard. And I went to the website of my housing association just to fill in a repair request. And they were like, in which room is the problem? I have a studio. I don't know. It's just in my studio. And I was clicking back and forth between different options, living room, kitchen, whatever, to get to this meter cupboard option, but I couldn't find it. So I ended up just saying there was a leak in my kitchen because that one was the one that fit the best with the situation that I could find. But it wasn't exactly ideal. Like, luckily they managed to fix the problem, but I remember being very frustrated to have to use that system. And this also reminded me of a talk that I saw here at PyData Amsterdam back all the way in 2019, when the city of Amsterdam, who was also doing a talk on this stage just before we did, they were talking about a problem that they were having, which is that civilian citizens in the municipality of Amsterdam, they can submit a service request. And when they do a service request, that's basically anything that needs to be handled by the city of Amsterdam. Like, it can be a full garbage container or a noise complaint from a boat in the city somewhere. And the municipality of Amsterdam has to act on that. And in order to act on that, there's obviously, you do something else when there's a couch on the street and it's like in the way and blocking something. There's a different thing you should do than if a drunk person is causing a disturbance or there's a lot of noise coming from a boat. So they needed the specific like incident code, essentially, category, so they know how to handle it. But the problem was that people had to click that, and they first had to click a main category and then click the subcategory. And people are just not used to doing that, so they very often just click the wrong thing, and a garbage truck would be sent to a boat, so that's not ideal. So the solution that they proposed in that talk was a system something along the lines of this, where they just get rid of all the submenus and all the incident codes and all the picking the categories. There was just this little text box over there where you could type your problem in regular Dutch like a person would. And there would be a very simple text classifier in the background running to classify what was most likely the main issue and the sub-issue that it belonged to. And this was 2019, so it was way before LLMs were like really integrated in the work that people were doing. This was a very simplistic text classifier. And this is obviously just one very simple way to adjust the underlying system and remove a huge burden from the people making the annotation, while at the same time increasing the correctness of the labels. It certainly solved a lot of issues in this case that stems from systems not being easy to use or being hard to navigate. But obviously that doesn't remove the ambiguity of what we encounter in the real world, like the example with the homeless or drunk or confused person that you were dealing with. So sometimes people's interpretations simply vary, and sometimes there's just not a right box to pick. And sometimes people simply don't have the right knowledge.
And this lacking of the right knowledge, that's something that's quite understandable, right? In case of these complex kind of categories and click-through menus as we discussed so far. So let's talk about some really basic data instead. For police reports, one of the core things that you really should be able to rely on is the location. So in what kind of location did an incident take place? Now that seems very straightforward, right? Not so much. On this slide, you can see an apartment, a flat, a gallery apartment, a maisonette, and an upstairs apartment. I would not for the life of me understand what the difference between these is. In fact, I found all these pictures together, but I already forgot which is which, so I could not tell you. So how do you think a police officer deals with that? This is how, most of the time. They tend to pick a generic kind of category, because who the hell has time during their very busy workday to Google all these different kind of buildings, find out exactly what the difference is. And this is for buildings. We all presumably live in them or are quite familiar in them. What about categories that you really don't know anything about, like camera equipment, for example? It's even more complex. Now, while we actually try to add these specifications to get more information, we end up with less information altogether because even for categories that seem obvious like this one, you're asking too much. You're asking too much from police officers who are not data entry specialists, nor are they architects or any other kind of item experts. Now, of course, all the things that we discussed in the first part already play a role here as well, but I wanted to look a bit more at how that impacts your job of data interpretation. Say your data shows a decrease in burglaries in apartments. Now, of course, one possible explanation is that there are less burglaries in apartments, so you can report good news to your supervisors and they can, for instance, plan less patrols in these locations. But there's other explanations as well. Maybe, like me, these officers don't really understand the differences between these buildings. So if everything ends up in this category of other, then of course your other numbers are going to go down for the specific categories. Or it can be a system thing. And one thing that happened during my fieldwork with the police was that the order of this list of buildings changed. So first it was alphabetical, apartment would be way at the top, and then suddenly it was not. Probably a very good system-level reason for this, right? But the police officer's work actually changes because of such a simple change. Maybe apartment is harder to find and they just go with whatever close option comes to the top now. Or Or there can be external factors that really don't have that much to do with humans. For instance, if the municipality decided to demolish a bunch of apartment buildings, then also your final number is going to go down. You can't really interpret this stuff fully without knowing that kind of context, and that makes your job a lot more difficult, I think.
And from my perspective, from the data side of things, I don't really talk to Sandra. I don't know Sandra. She apparently said this. The thing that I see is not Sandra saying, you know what, I'm just going to put everything in the other category because who has time to do this? The thing that I see is something like this. It's just I analyze the categories that I have, and I think, you know what? It seems like that other one is really, really big. And if you approach it from like more of a data-y perspective, there's definitely some things you can do about this. First of all, don't just accept it. Maybe the default would be if there's an other category that's not interesting, we'll just drop it. But in this case, it's obviously a very big category, so you wouldn't just drop it. But for instance, one of the things I did in the past in one of my projects was, oh, I see that the other category is really big. I'll just do some like semi-supervised learning where I try to reclassify things that are in the other category, put them in other categories. And that works. That's definitely something that worked in that particular project. But it's really just approaching it from the data side and seeing this as noise in the data instead of seeing the reality of Sandra's comment that was behind it. So I think there's definitely some things you can do as just looking at the data specifically to deal with this, but you kind of miss that context very often. Why is this happening? And instead of just dropping everything that's in other or reclassifying it, maybe there's other things you can look for. Is there, for instance, a specific time point after which a lot ended up in the other category? Maybe that means that there's some system change going on there. There's things you can do to kind of dive into that and solve the issue that you see here that has a lot more to do with finding out what the motivations of people were than simply what the data says about it. You might be tempted to think as well, if so many things are ending up in other because people don't know the difference between all of these different categories, why don't we just train them better? Why don't we just train the people who use the data entry system properly? And that can certainly help. I've run annotation projects at Cohere, and we discovered that training people is really hard, especially if you just give them a long set of instructions. That's usually not going to work. There's definitely some things you can do there to make it easier for them. Give a lot of examples. The most important thing being, be iterative about it. So don't depend on one single training and assume that they will do everything correctly for the rest of time, because that just doesn't happen. There will be things coming up that you didn't anticipate before you made your training that you have to kind of react to and retrain people. But that still has the problem that is really approaching it from that data person perspective. We want our training data or our analysis data to be better. We want our visualizations to be better. So we just go back to those people and say, hey, this is how you're supposed to do it. But like nurses and the police, they're really, really busy. They don't have time to be retrained, especially in very large organizations where there's a lot of people doing this data entry. There's simply not enough bandwidth for them to constantly be retrained on this thing. So it might be tempting to say this, but it's not really a solution.
So aside from this argument of bandwidth, there's something that we also should really not forget when we're talking about these humans in your data. And that's that these humans are humans. They are not superheroes or whatever. So they have bodies, they have minds that have limitations. They can make mistakes, they can get really tired. I definitely got very tired during night shifts with the police. And I was, of course, also doing data collection. Also, as I already mentioned once, they don't really care about data creation. They care about being a good police officer. So if they're forced to choose between accurate data or doing a good job as an officer and doing right by citizens, by colleagues, then they're always going to choose that. They're never going to pick the data perspective there. And then the nature of police work, the type of work that they do also doesn't help, especially in emergency response. Emergencies take precedence, thank goodness. Which means that data work is often interrupted, and there can be a lot of time between something happening and then writing that down. So that can lead to forgetting things, making mistakes. In fact, because I was constantly making notes during my fieldwork, I was quite often asked, oh, what exact time did this happen again? Now, what does that mean for the data science side? Of course, your data can have inaccuracies, and often that's not that bad, I guess. For instance, if timing is just a tad off, or if there's common spelling mistakes, things like that, that's stuff you can deal with on the data science side. But sometimes inaccuracies can seem innocent, but are less innocent than that they seem. And with that in mind, I have one final example that I'd like to share with you. During my fieldwork, I think it was actually the first day I did my fieldwork with them, and I was sitting at the kitchen table where a man and a 4-year-old daughter were sitting, and they were quite upset, especially the man. The daughter was playing at that time. The thing is, their neighbor had been standing in front of their door that morning with a big knife in his hand, threatening them. So the guy was explaining to the police what had happened exactly, and he was quite upset. He was visibly shaking when he was talking to us. And during his explanation, he told us that the neighbor was a bit psychotic. So the day went on, a traffic incident and some other stuff happened, and hours later, when the officer was finally writing down the report, he wrote down he was in a psychosis. Now, that's a small textual difference, but a big one in terms of interpretation. The first one is quite a soft-spoken way of saying it. You wouldn't really take that statement seriously, and it makes a lot of sense considering how upset this guy was, that he would say something like this. But the second one, that seems like a factual statement, and especially talking police, that can have big consequences. Now, as far as I know, this doesn't currently happen at the police, but you can imagine, for example, that the second statement could lead to a flag for psychiatric evaluation, for example. So potential big impacts here, but I don't think this is something you can really solve as a data scientist. These kinds of things, this humanity actually of your data, it's bound to happen. Yeah.
So Isabelle told us a lot of things about things she saw in the Dutch police system, which is not the only organization dealing with this kind of thing. And I think we can summarize it by saying that we saw 3 problems, essentially, with datafication of organizations, where data is a byproduct of the work that's actually being done. The first one is essentially just the humans doing the work, and I think it's very important to realize that's not their fault. Like, there are things that are just hard about data entry. Sometimes it's just not clear-cut. Sometimes there are so many boxes. Yeah, the data is very often created by humans who have very little context of what the data is going to be used for later, other than communication with other people who are also in the field. It's an administrative thing, and it's not their main purpose to create data that is easily to be used for creating dashboards and visualizations and that sort of stuff. They have no interest in creating the best and the noiseless and most accurate data, because that's not their job. They do not benefit from that, and it's also not made easy for them by the systems that we use for data entry. Sometimes the systems are simply very limiting in expressing what's actually happening into what needs to become the data. Yeah, so they're very often designed from the perspective of what data do we need, and not necessarily from the perspective of how does data annotation or data entry work in the real world, which makes the data hard to trust and also hard to use. And the last issue, and I think we've alluded to that a lot, but we didn't explicitly say it yet, is kind of the data people who tend to also not talk to Sandra, who told us, like, I'm just putting everything in the other category because this is hard to deal with. We just looked at it from the perspective of the pie chart that we saw, where we're like, okay, there's a lot going on in the other category. Maybe we should deal with that. But we tend to forget that this data is not created by systems, or automatically it's created by humans, and it lacks context. Which brings us to the possible solutions. One of them could be, hey, can we solve it on the human side, the people doing the data entry? And I think we already covered a little bit. That's hard. Obviously, you can retrain them. You can instruct them better. You can tell them what the difference between an apartment and a gallery flat is. But humans have limitations, and that's OK. The other thing is, can you design the systems to be better? And I think we saw an example of that, for instance, from the municipality of Amsterdam, which made a much nicer to use system, and it definitely removed some of the limitations that people were experiencing, and also improved the quality of data coming out of that. But unfortunately, we don't always, I know that I, in my role, don't always have the control over dealing with how systems and UI is developed. So that's maybe also not the only solution there. So that leaves us with the question, what can we do as data people? If we cannot change the people, if we cannot change the systems, where does that leave us? And I think it starts with an understanding that in interpreting our data, we shouldn't only approach it from the data side, from that pie chart that we saw, but we should really be involved and look at what the data creation process is like. So we shouldn't say, help, there are humans in my data, but accept that there are humans in our data. And ideally, see if you can get a better sense of what's going on when that data is created. Maybe tag along if that's a possibility, like you did with the police. I did that in my work as well, where I tagged along with a radiologist for a day, and it really gave me a really good understanding of what it is that a radiologist does, which was very useful for me in my job at the time. So that's essentially our point. Accept that there are humans in your data, there are humans creating the data, and see if you can understand what they're going through a little bit better, because it really improves the quality of your own work eventually. Thank you.